There are a couple of contexts in Maya where we do actually store point or geometric data onto the geometry. One example is in Bifrost, which we'll look at in a minute. The other example is with the particles. So it's very Houdini, similar to Houdini in its behavior there. So let's just quickly have a look at some of the particle stuff. I'm going to just create an emitter, an end particle emitter here, and we'll just shoot off in a bit of a direction there. Is that enough speed? No. Where's the speed? So along axis, there it is. So we'll get them to shoot along the axis, which I'll just rotate around a bit. There we go, a bit more speed. Cool. So the particles are flicking out there. And what I'm going to do is just create a collider for them. Since this is N dynamics, we can turn this into a passive collider. And we'll see our particles shooting along. Let me get rid of the grid. And they're sliding along there. So if we actually look at our N particles, or rather the particles in Maya, we can get, let me just select them, we can get per particle attributes here. So these attributes do actually live on the particles themselves, and we are changing the data per point. So each point can have its own unique data. So this allows us for some very powerful control. Let's add some color so we can see what's going on. If I go to color, we can add a per particle color. And the way Maya works is you create expressions, and you have two basic types for the particles within Maya: a creation, which sets up the initial state, and a runtime, which varies things as time goes on. And it's very powerful because, as I said, you can store in arbitrary attributes per point and vary those per frame to get some very interesting effects. So if I just create a creation expression for the color here, let's set this to, say, black. So I'll just create a vector there. Ooh, just set the color to black. So if I press play, you see all my particles are now black. And let's mess around with that. So there's some interesting attributes that we can add here. So if I just again select the particles, we can click on General and go to Particle. And these are all the particle attributes that we can use. We can use arbitrary ones ourselves, but we're limited here to 5 scalars and 5 vectors. Any more than that, well, Maya just doesn't do it because there's no real scope for that. But the ones I want to actually look at is this interesting one here, collision U. Let me just add that. And we can add more. The more we add, obviously, the slower we get. So the collision U will tell us where in U space on the geometry that the particle has hit. So if I just run that through for a sec, we can actually go to the shading here, and we can turn this to numeric, and we can display what's going on. At the moment, that's showing me the particle IDs. But we can type in collision U just to preview what's going on. And we can see that when I press play a bit, when they've not hit, the value is -1. And when they hit, they're reading the U value. So look, here it's 0.3, up here it's 0.7. And as we get towards the edge there, it's going to hit 0.1. And we can use that to do interesting stuff with our particles. So let me go back to points. I'm going to come down here and do this time a runtime expression. So I'm going to say that my color now at runtime is going to equal to, we'll have the vector, and what we'll do is we'll run the collision U into the red, and we'll keep the green and blue dark. So now hopefully we should see a red color brightening up as the particles slide along the surface. So the red is now connected to the collision U. And as you can see, that's exactly what's happening. Particles start off here with a low value, and as they creep across the surface, the red gets brighter and brighter. So as you can see, by being able to add sort of attributes and control attributes and read data from the scene onto the points individually, gives us quite a fair bit of control. So basically we're using particle expressions this time to extract information from the scene and update the geometric particles per particle for every frame. The equivalent for doing that in Houdini would be Vex. Let's just pop over to Houdini. Now the interesting thing about Vex is Vex lives in all the contexts, and Vex doesn't just need particles, it'll just work on geometry, because essentially in Houdini, Houdini just sees everything as points or particles, and we just work with everything like that, whether it be points or particles. So let's just have a little look at that. So I can just drop in a wrangle node. This will allow me to write snippets of wrangle, and we can change attributes here. For example, I could say at CD for the color equals set, and we'll set this to black like we did just now. Oh, there we go. Why is that not typing? Let's try that again. So 0, 0, 0. So we'll set our vector to black, and as you can see, I've created a CD attribute and colored that all to black. We could even take sort of the, or actually let's do this on the red component. So we could even take the red component and base this off the, say, at p.y, because that's another attribute, and we can just read that in here very simply. So now the red is based off the position in y, and there's the p.y attribute. So if I actually now play the animation that translates, you can see the color changes depending on that position in y. So again, just like in Maya, or the particle expressions in Maya, the ability to be able to read scene or geometric data into directly into the points and change the attributes directly allows for some very powerful control. The difference is in Maya we can only kind of just do that in the particle context as particle expressions, but in Maya, in Houdini rather, we can do that with these wrangles by writing bits of code anywhere in Houdini in any of the contexts. So these wrangle nodes, which incidentally write Vex, can also be used with what we call VOPs. Let me just make a point VOP. So VOPs is just sort of visual Vex operators, so they're just nodes equivalent of the Vex code. You could just write everything in code in Vex code in the wrangle nodes, but often it's easier, especially if you're using noises and stuff, which are quite complicated expressions to write, to use a point VOP. So let me just make another sphere and just show you how VOPs work. So let me just set this to polygon, make sure we've got enough divisions on there. Let me pump that into the point VOP. If I go inside, you'll see it's another sort of context, essentially a context within a context. And what we're doing here is we're actually bringing in the geometric properties. It's not really, in Vex actually, it's not looping over every point, although more it's parallel processing them all simultaneously. Which is an interesting thought in itself, but it means it's very scalable. We prefer to do things in Vex and VOPs if we can. So the kind of stuff you could do, let me just demonstrate it, is let's add some noise. And what I'm going to do is let's add a normal actually to our sphere. We'll add some normals first. So I've got a noise, and I'm just going to plug the position into the noise so we can look up the 3D noise. And then what I'm going to do is I'm going to multiply that. Or rather, I'm going to take the normal and I'm going to multiply the noise with the normal, which will perturb the normals. And then I'm going to add those normals to the existing point positions. So essentially, we've got the point position, and it's adding a certain amount in a direction of the noise of the norm in the direction of the normal based upon the noise. So let's look at the result of that as the new point position, and you can see that's basically built a deformer there. If I just recalculate the new normals afterwards, we can see nice shading on it. And the nice thing is I can come into the noise here and I can add the frequency, can change the amplitude, and well, you can see it updates in real time. We can do other interesting stuff. For example, we can use other attributes. So for example, say I go to paint attributes here. This will let us create an attribute called mask. That's the name of it there, called mask. So if I just hit that and paint, let's just make the brush a bit bigger. So I can paint some attributes here or bring them in with a texture map. And again, in the VOP here, we can bring in those attributes. So if I use a bind node in Houdini, this will allow me to bring in that attribute. You can see it here on the geometry there called mask. And if I just filter the list, you'll see there's different values. Let's call this mask. Make sure it's the right data type. Well, that's all lowercase. Make sure it's the right name, case sensitive, and it's the right data type. And then that will bring it in. And then we can actually just multiply everything by the mask. And what you can see there is our colors are affecting, if I just paint some more, where the noise is. So I can paint the noise on or paint the noise off. So that gives me really quite powerful control here using these VOPs. So just to remind you, the VOPs pulls in the points, and then we're able to access these sort of attributes per point and manipulate them. And we can add our own arbitrary data as well. In this case, a value called mask, which I then brought in and used that to vary the effect. Now we can actually do something very similar in the new Bifrost board. So let's pop over to Maya and have a look at that.